Okay, welcome back. Sorry, we ran out of time there, so we're into part 2. So the question we got onto was how many 6s went to 15, which was 2, because 6 times 2 is 12, and we had 3 left over. So that meant that 6 didn't go into 495 a whole number of times, so we're moving into the decimals. So what's my first decimal? Well, 0. Every number, in fact, has 0.0 after it if it's a whole number. We just don't write it. So let's carry the number left over onto that 0. So 6 into 15 with 2, remainder 3, and we pop the 3 down here. So now we've asked the question that we've been asking the whole time. How many times is 6 going to 30 now? Oh, well, conveniently, that's 5. And we're finished. There are no 6s left over. So our answer for 495 divided by 6 is 82.5. So it's just, so that's not a decimal point, that's just a little marker. So we just use the regular bus stop method. If we have some numbers left over, we pop a 0 down and we'll just keep going. Okay, so calculate the volume of this cuboid. So you might know the hard and fast rule for volume, which is just multiply the 3 numbers together if it's a cuboid. Let's ask the question of why. Well, let's start with this front face then. So what about area? What if we started with the question of area? So we have to find the area of this front face. It has a width of 8 and it's a height of 4. Because that length there is 4, all of the lines going upwards are also going to be 4. So if I said area, well, we'd say that's 8 times 4 and that's 32. Okay. And in fact, what we mean by that is there are 32 little squares that would fit inside that front rectangle. You may remember that from the first time you learned area. So we'd have, let's break this up into 4. There we go. And then we'd break this up into 8. So halve it, halve it, halve it again. Roughly, there we go. So 32 even squares in this front face. So when I move into volume, I'm not asking it now anymore how many squares are in that front face. I'm asking how many cubes are in the whole shape. So now, how many cubes would we fit backwards? Let's have a look at a cube. Not too bad, there we go. So each cube would have a depth of 1 centimetre back. So if I've got 32 square faces filling up this, how many cubes could I fit backwards? Well, I've got 6 spaces to fill them up into going backwards here because there's 6 centimetres. So for each square I can see in the front face, I could fit 6 cubes going back from each square. So my final calculation then would be 8 times 4, which is 32. And then I'm going to do those 32 squares, turn them into cubes, and so I'll have 6 of each of those. I'm going to do 32 times 6. Okay, and for 32 times 6, I was going to do it mentally. I think I'd probably do 30 times 6, which is 180. 6 times 3 is 18. And then 2 times 6, well, that's 12. Pop it all together, and we get 192 centimetres cubed, because we literally mean each one of these is 1 cubed centimetre, or a cube that has lengths of 1 centimetre for each of its lengths. Okay, so for question 7, we are going to multiply 32.21 by 1,000. So every time we multiply a number by a factor of 10, all that happens is the digits move along the place values. Okay, so if we've got 34.21, if I was to multiply it by 10, well, then that would become 342.1. You could put a 0 there if you wanted to, wouldn't make a difference. And then if I multiplied it by, so that's the first 10 from the 1,000. If I multiplied it by 10 again, well, then we'd have 3,421 point, again, 0 if you fancied it. And then we now need to multiply by one more 10, because there are 3 zeros in 1,000, or 10 times 10 times 10 is 1,000. And we'd end up with 3,421. But I've moved them over, so I now need a placeholder of a 0 there. So we end up with 34,210. Okay, so we've taken this number and we moved it 3 places. We've got 3 zeros in the 1,000, or 10 times 10 times 10 to the left. So for question 8, round this number to 1 decimal place. So for rounding, we find the degree of accuracy we want. So here's my first decimal place in the tenths column. Okay, and now I need to ask myself a question. Is this number here closer to 991.5 or 991.3. And I use the second digit after the degree of accuracy that I want to help me look at that. So if we look at it in its own right, is 39 closer to 40 or 30? Well, our rule is, and hopefully you know this, if the number next to the number we're rounding is 5 or above, we round up to the next number. If it's 4 below, we round down to the number below. So here we're going to round the 39, if you like, up to 40. If you want to think of it as tens, we can simply say we're going to round the 3 up to a 4. So our answer becomes 991.4. Okay. If this number here had been 34, so that's a number that's below 5, I would have rounded down to 991.3. Okay. For question 9, you might have Googled this. What's the mean of these numbers? So the mean is our mean average, which means add up all the numbers we've got here and divide by how many we've got. Now, where might you have seen this in real life? Well, you might have seen it, for instance, in sport when someone talks about average goals scored per game. So to find average goals scored per game, you'd add up the number of goals scored across the season for a particular player, and then you divide by the number of games they've played, and that gives you the average goals that they've scored. So for instance, if a player had scored 2 goals in every game, you'd add up 2, 2, and 2, you get 6, and it would be 2 goals per game, as you'd expect. Okay. Now this one it's a little bit different. We've got numbers all over the place. So we're going to have to add up first all of these numbers here. And for time, I'm just going to pause it and write the total down. Okay, so our total here is 201. I can't think what sport that would really replicate, but say it's, I don't know, basketball perhaps or something. I think that might still be a bit extreme. Let's say they scored 201 goals across 1, 2, 3, 4, 5, 6 games. So I do, for my average, my mean average, I'll do 201 divided by 6. And maybe we'll go for a calculator for this one. So on average, we get 33.5 goals per game. Okay, so mean is add them up and divide out how many there are, divide by how many there are. And then finally, question 10, what's the highest common factor of 24 and 36? So I guess the first question is, what's the factor? So our factors are our numbers that multiply together to make those numbers, and they normally come in pairs. Okay, so for instance, 24, well, 1 times 24 is 24. So 1 and 24 are factors of the numbers. And we can quickly see a rule there, which is that 1 and the number itself will always be a factor of any number. We could do 2 times 12. That makes 24 as well. So 2 and 12 are factors of 24. We could go for 3 and 8. That's also 24. We go for 4 and 6. That's also 24. Okay. As we can see, the next number after that will be 5. Well, 5 doesn't go into 24. And then the next number we've already considered is 6. So these numbers get smaller as these numbers get bigger. So there aren't going to be any more factors that are whole numbers. Okay, so it'll be whole numbers, which sometimes we call integers. For 36, if we do our factors, we've got 1 times 36. We've got 2 and 18. We've got 3 and 12. Doesn't look like a 2, isn't it? 3 and 12. We've got 4 and 9. 5 doesn't go in, and then we've got 6 and 6. So here we have a double factor, so we just count the 6 once. Okay, so there are our factors. What's the highest common one? So we want one that is both the biggest, but in both. And we just take a different color here. We can see that 12, that looks like a 12. And there's a 12 over here too. So our highest common factor is 12. Now there are other ways to do that, which you'll hopefully see at second school. You may already know if you've used Venn diagrams to do that problem before. That's brilliant, you're well ahead of the game. Okay, so if you found those a little bit too tricky, try our beginners. If you found them a little bit too easy, try our advanced. There's an extension question or advanced question as well. Well done for taking part, that's what counts. And hopefully see you for week 2.